In this video, we're going to look at how to create a geological profile in RAMP. In previous videos, we introduced the main profiling concepts and some of the terminology. And we also, in another video, looked at how to create a simple profile. If you haven't looked at those videos yet, I suggest you check them out because some of the concepts, terminology, and workflows are better described in those videos. We're going to skip over those some of those aspects more quickly in this video. So let's look at what a geological profile is. Here is one that I've created earlier in the RAMP profiling tool, and this is shown in the RAMP profile viewer. Essentially, it's a stacked profile where we have a series of different value fields that we can then render units or intervals between. This is the basic premise of a geological profile. And we're going to look at how to recreate this profile using some of the raster data sets in my sample data folder. So we're going to use the same basic workflow that we've used before. That's generating a seed profile, densifying that profile, and then finally appending values to it. So this is going to be no different. We're going to follow that particular workflow. Before we start the profiling processor and executing the workflow, we need to prepare the raster data sets that we're going to use as input. Let's do that now. So I'm going to add some data sets, and the first one that I'm going to add is my bathymetry data set. So we're going to use a case where we have a site survey and we have a series of horizons that have been picked and generated into rasters below the seabed. So let's add the bathymetry first and render it. Okay, now let's add some of the horizon data sets in here. So we have the R1 horizon. That's what that looks like. We have the R1A horizon. That's what that looks like. We have the R2 horizon. That's there. And we have the R3 horizon. And we have another horizon. Whoops, we have another horizon in here. Called the cap, R3 cap. So let's add that in and render that guy. Okay, and that's what he looks like. Let's just inspect some of the values for these. So the bathymetry appears to have negative values, and the horizon data sets appear to have positive values, and looking at the name, they appear to be, and I know them to be, values that are below seabed. So in order to do this, we need to ensure that not only do all these rasters have the same coordinate reference system, they also have the same value datum or vertical datum. So in this case, the negative values are values below sea level. So what we're going to do is we're going to convert these values using raster calculator or raster calculation to values that are also below that same datum, so below sea level. So I'm going to do that using the raster calculator. I'm going to declare my seabed as this one. Oops. And I'm going to then have my raster that I'm processing. Let's do R1 first. And this will very simply be, all I need to do is basically say return seabed minus raster 1, and that's going to be my new data set. So let's process that, and let's render that and make sure now that we have negative values as we're expecting. Okay, so this one is R1. I'm going to do the same now for the other data sets. So if I open up my calculator again, I'm simply going to change this one to R1A and execute it again. Okay, so I have all of my horizons in here now that have been corrected such that they are negative values below the sea level datum. Okay. Now what I'm going to do is create a seed profile. I'm just going to draw a line from here to here. And that's going to be my seed profile. In fact, I might actually draw it so it's a bit shorter. I might draw it from here to here. Okay, that's now my seed profile, and I'm going to export that seed profile. And we'll call it seed profile, and it will be called seed. Actually, we'll call it tutorial.profile. Okay, now we can use the profiling processes to densify this profile. So let's do that first. We're going to use the tutorial profile, and we're going to densify it using a distance of every, let's go 5 meters. Again, I don't need to define an ellipsoid, so let's densify it that way. And let's create a couple of, let's not create some offsets, let's just leave it at that. We have one single profile that we're generating. Now let's go and append data to the profile. So we're going to use the stacked method, and we're going to define all the rasters that we'd like to include in the stack. So here we go. Those are all the rasters I want to include in the stack, and I'm going to give it, actually what we'll do is we'll change the order of some of these as well. We'll put the cap above R3. Okay, then it's asking me for what do I want. So I want to give them names of seabed, R1, R1A, R2, R3, cap, and R3. Okay, the interpolation method we're going to use is bilinear. And let's see what happens now when we use this stack append. Okay, let's open this up in the profile viewer. So open the profile viewer, bring it over here, and we'll open the tutorial profile. Okay, great. What you'll notice is that there's only one center line in here. So basically there are no offset profiles. We're only really looking at one single profile, and because there's no offsets, there will really be no cross profile either. Let's go ahead now and use the profile viewer quickly to set up some things. So the units along the profile are in meters. The values are also in meters. They're depths below mean sea level. The coordinates are in meters, and we don't have any cross profile data. Let's quickly just look at the profile viewer and how we can start to make things look interesting in here. We're going to rename this, so this will be called seabed. We're going to label it R1, R2A, they will all be the same, but let's make these italic. Whoops, that was the color. So let's make that italic as well. We're just going to call this as cap, carbonate cap. Yep, R2, and here's R3. That'll also be italic. So let's make the seabed line blue. Let's make it that blue. And let's make the seabed go down to, let's say, the red line here. So we're going to now extrude this so that it has a color fill down to the red line, which is R2. So we're going to take it down to R2. And you can see it now has a color fill. Let's change that color to something a little bit lighter. So let's use a yellow color like that. Now let's draw the R1 line as a darker sort of yellow, like this maybe. Yep. And now we can fill from that line, so R1, back up to seabed. So let's do that. So we're going to say, color me up to seabed, and let's change the color fill to something like maybe like that. So you can see how you can quickly build sort of stacked profiles. So let's take R1A and let's extend him down to R2 and give him a different color. Let's make him something interesting like that. And then we're going to take R2 to R3. Maybe an even darker color like that. And then this cap here will be cap to R3. In fact, we could say R3 to seabed. Whoops, so R3 to none to the base. It's like that. And you can see we've pretty quickly built a very simple geological profile that will also have labels applied to it based on what we've set up here. We're going to look at the ramp profile view in a lot more detail, how you set things up and how you can export to different graphical formats. But this video has been an introduction into creating geological profiles with ramps, so I hope it's been useful for you. Thanks for watching.